Today we will see the solved examples based on the maxima and minima. So let us start our session. The first example is find the maximum and minimum value of f of x is equal to x cube minus 3x square minus 24x plus 5. So let the given function is consider the given function, differentiate it with respect to x, then find its derivative 3x square minus 6x minus 24. This is the derivative of the given function. Now to have the maximum and minimum value, we must have the first derivative becomes 0. So at extreme values of the function, first derivative becomes 0. So f dash of x is equal to 0 implies 3x square minus 6x minus 24 is equal to 0. Taking 3 common, then x square minus 2x minus 8 is equal to 0. Now we solve this quadratic equation. So we get x is equal to minus 2 and x is equal to 4. So these are the stationary points, or we can also call it as these are the turning points of the function. Now this is the first step to find the maximum and minimum value. First derivative equated to 0, find the roots of that particular equation, solve it for x. So whatever the points you get that are turning points or stationary points. Then we find the second derivative of the given function. So we will differentiate the equation 2 again with respect to x so that we obtain the second order derivative. Now the next step is we have to check the sign of this second derivative at these stationary points. So take the first stationary point, x is equal to minus 2. Put that minus 2 in the second derivative. What we get? We get minus 18. So which is less than 0. So what is the second derivative test? It tells us whenever f double dash, the second derivative is negative, the function will have maximum value at that point. So at x is equal to minus 2, f of x has maximum value. Now how to find the maximum value? We will put x is equal to minus 2 in our function to get the maximum value. So the maximum value is 33. Now the second stationary point x is equal to 4. So put x is equal to 4 in the second order derivative, we get 18. So at x is equal to 4, the function will have minimum value because the second derivative is positive. Second derivative is positive, so function has minimum value. Second derivative is negative, function has maximum value. And how to find the minimum value? Again put x is equal to 4 in the given function. We obtain the minimum value. So what are the local maximum is 33, and we obtain the 33 at x is equal to minus 2, and the minimum value we obtain is minus 75, and we got this value at x is equal to 4. So this is the maximum and minimum value of the given function, that is extreme values of the function. Now a wire of length 120 centimeter is bent in the form of a rectangle. Find its dimensions if the area of the rectangle is maximum. Let x and y be the length and breadth of the rectangle. Okay, x and y be the length and breadth of the rectangle. Then the perimeter of the rectangle is 120 centimeter because we have formed the rectangle from a wire whose length is 120 centimeter. So the perimeter of the rectangle must be 120 centimeter. But the formula to find the perimeter of the rectangle is 2 times x plus y is 20. That is x plus y is 60. So y is 60 minus x. So this is the breadth of that rectangle. Now what is the area of the rectangle? What is the formula to find the area of the rectangle? The area of the rectangle is length into breadth. So length is x, breadth is y. But what is y? Y is 60 minus x. So take their multiplication. This is our function. This is our function which we have to optimize or maximize or minimize. So differentiate this with respect to x. dA by dx is 60 minus 2x. This is equation number 2. Again, to find the maximum area or maximum value, the first derivative must have 0 so that we get the stationary points or turning points. So 60 minus 2x is 0, which implies x is equal to 30. So we get the length of the rectangle 30. Now we will check the sign of the second derivative at this point. So differentiate with respect to x, d2a by dx square, it comes out to be minus 2 because derivative of 60 is 0 and minus 2. So second derivative is less than 0. So for x is equal to 30, we get second derivative less than 0. Hence, at x is equal to 30, the function will have maximum value. That means the area of the rectangle is maximum when the side is 30. So length is 30. So what will be its breadth? Then breadth is y is equal to 60 minus x. So 60 minus 30 is 30. So we conclude that the area of the rectangle is maximum if and only if the length is equal to breadth is equal to 30 centimeter. That is, the area of the rectangle is maximum if it is a square. If it is a square. The next example, a rectangle sheet of paper has its area 24 square meters. The margin at the top and the bottom are 75 centimeter each and the side is 50 centimeter each. What are the dimensions of the paper if the area of the printed space is maximum? Suppose this is our paper sheet whose area is 24 square meters. Now all the dimensions we will consider in the meters only. Now what they are saying, the margin at the top and the bottom are 75 centimeter. So from the top we are keeping the space of 75 centimeter. Similarly at the bottom also. Also the for the side it is the margin is 50 centimeter. So from this side we will skip 50 centimeter and from this side also we will skip the paper 50 centimeter. So what are the dimensions of the paper if the area of the printed space is maximum? So this is the space where we are going to print and we want the dimensions of the paper of the printed space. This area we want maximum, so that what are the dimensions? Okay. So this 50 centimeter means how much meter? Now 75 centimeter means how much meter? We know that 100 centimeter is equal to 1 meter. 100 centimeter is equal to 1 meter. So 50 centimeter is equal to how much meter? You can find out it. Let x meter and y meter be the width and the length of the rectangular sheet of the paper respectively. So area of the paper is given 24 square meter. So what is the area of the paper? X into y is 24. So from this we can calculate y. Y is equal to 24 upon x. Now after leaving the margins, the length of the printing space is x minus 1 meter and breadth of the printing space is y minus 1.5 meter. Now how they came here, x minus 1, y minus 1.5. Hmm? So this is 50 centimeter we left. This is also 50 centimeter left. So actually we have left 50 plus 50, 100 centimeters. But 100 centimeters is nothing but 1 meter. So from the total length we are leaving 1 meter length. So x minus 1 meter. For this 75 plus 75 it comes out to be 150 centimeters. That means 1.5 meter. So from breadth we have to subtract 1.5. So y minus 1.5. So what will be the area of the printed space then? The printed area of this printed space is x minus 1 into y minus 1.5. But what is y? Y is 24 upon x. So put that value here and simplify. So the area is 24 5.5 minus 1.5x minus 24 by x. So differentiate with respect to x, we get minus 1.5 plus 24 by x square. Now for the maximum value, this first derivative must be equal to 0. So this becomes 0. So we get 1.5x square is equal to 24. So after simplifying, you get x is equal to plus minus 4. But x is not equal to minus 4 because it is a length. So length never negative. So we have to take x is equal to plus 4 only. Now again differentiate this equation with respect to x so that we obtain the second derivative. Okay, so the second derivative is minus 48 upon x cube, minus 48 upon x cube. So x, for x is equal to 4, the second derivative is less than 0, which is negative. So the function will have maximum at x is equal to 4. So the printed space is, the area of the printed space is maximum for the length x is equal to 4. So put x is equal to 4 in y is equal to 24 upon x. We get the breadth of the paper sheet. So 24 upon 4 is 6. So the area of the printing space is maximum when the width of the printing space is 4 meter and the length of the printing space is 6 meter. Okay, so this is the solution of this problem. Now, an open box is to be cut out of the piece of square cardboard of side 18 centimeter by cutting off equal squares from the corners and turning up the side and find the maximum value of the box. So let the side of the each box of the small square cut be x centimeter. This is the square box. And what we are doing? In that four corners we are cutting, we cut the four corners and the length and breadth of that cutted corner is x centimeter. Okay, so the each side of that box is made up of will be 18 minus 2x. Why 18 minus 2x? Because the total length is 18. Total length is 18. Now we have subtracted here x, 1x, and here another x. So we are subtracting 2x. So 18 minus 2x. Similarly for this. Now V be the volume of the box. Now how to find the volume? The area of the base into height gives the volume of the box. So area of the base is, what are the dimensions of the base? Dimensions of the base are 18 minus 2x into 18 minus 2x. And what is the height? Because we are going to curve this side having the length x. So the height of that box will be x. So 18 minus 2x, okay, its its square is 324 minus 72x plus 4x square into x. After multiplying, you get the equation in terms of x, that is the volume of the box. Now we will differentiate this function with respect to x. So this is our dv by dx. Now for maximum value, this for dv by dx must be equal to 0, as our second derivative tells us that for maximum value first derivative becomes 0. So equate it to 0 and find the roots of this equation. The roots are x is equal to 3 and x is equal to 9. Now, but x is not equal to 9. Now, why x is not equal to 9? You have to tell me. If you take x is equal to 9, so we are cutting one corner 9 centimeter, the other corner 9 centimeter. So totally you are cutting 18 centimeter, but the total length is 18. So how there will not be any paper, and you will not able to complete a box. So we cannot take x is equal to 9. So x is equal to 3 is the possible value only. Now differentiate this second equation again with respect to x. What you get? 24x minus 144. Now put x is equal to 3 in this equation. What you get? You get minus 72, and which is already less than 0. So for x is equal to 3, the function will have maximum value. So the volume of the box is maximum when x is equal to 3. And what is the maximum value of the box? It is given by 18 minus 6 bracket square into 3, that is 432 cubic centimeter. This is the maximum value of the box. The next example we will learn is two sides of the triangle are given. Okay, this is the triangle, and out of these three sides, we have given the two sides. Now find the angle between them such that the area of the triangle is maximum. Let ABC be a triangle. AB, its side is C, AC, its side is B, and this is the angle A formed by these two sides. So let delta be the area of the triangle 1 upon 2 BC into side A. We know the area is 1 half BC into sine A. Differentiate with respect to A. We get d delta by dA is equal to BC upon 2 into derivative of sine A, because BC is constant, so derivative of sine A is cos A. Now for maximum value, the first derivative becomes 0. So d delta by dA is equal to 0, gives us BC upon 2 is cos A is equal to 0, but BC is non-zero, 2 is also non-zero. So we can divide throughout this equation by this factor and we get cos A is equal to 0. Now cos A is equal to 0 implies A must be equal to 90, because we know that cos 90 is 0. Now again differentiate with respect to x, we get minus BC sine minus BC upon 2 into sine A. Now if you put A is equal to pi by 2 in this equation in second derivative, it is clearly we can see that the second order derivative at this point is less than 0, because okay, the second derivative is less than 0, the second derivative become less than 0. So when A is equal to pi by 2, the area of the triangle is maximum. Hence, the area of the triangle is maximum when the angle between the given sides is pi by 2. That means the if we want the area of the triangle to be maximum, we must have to take the triangle to be a right angle triangle. Okay. The next example is the slant side of a right circular cone is L. Show that the semi-vertical angle of the cone of maximum volume is tan inverse of root 2. Let x be the height of the cone and r be the radius of the base. Now what is cone? You must know. The cone is look like this. Okay. There is something like this. This is the hollow cone. Okay, just keep in mind. So what they are saying, let x be the height of the cone and r be the radius of the base. So we have r square is equal to L square minus x square. This is our equation number 1. Now v be the volume of the cone. So what is the formula to find the volume of the cone? It is 1 by 3 pi r square x. 1 by 3 pi r square x. Actually, we are using h for height, but here I am using x. So 1 by 3 pi r square x. But what is r? R square is L square minus x square. So v is equal to pi by 3 L square x minus x cube. So differentiate this with respect to x. We get pi by 3 L square minus 3x square. So for maximum value, the first derivative must be equal to 0. So with that, you get x square is equal to L square upon 3. That means x is equal to plus minus L upon root 3. But we cannot take the negative value. So we have to take x is equal to L upon root 3. So differentiate this second equation again with respect to x. You will obtain d2y by d2v by dx square is equal to minus 2 pi x. So for any this value of x is equal to L by root 3, the second derivative is less than 0. Okay, which is negative, so it is less than 0, and all the other quantities are positive. So the for x is equal to L upon root 3, the given function will have maximum value. So volume of the cone is maximum when the height of the cone is L upon root 3. Now put x is equal to L upon root 3 in equation 1. This is our equation number 1. We will put x is equal to L upon root 3. What you get? You get R is equal to L root 2 upon root 3. Okay. Now if theta is the semi-vertical angle, then tan theta is R by x. R by x. Tan theta is opposite upon adjacent. So using the value in this equation, we get root 2. So theta must be equal to tan inverse of root 2 as required. Okay. Now find the height of the curved box of fixed volume so that the total surface area of the box is minimum, whose base is a rectangle with one side 3 times as long as the other. Now it is given that the box is a rectangular base with one side 3 times as long as. If x and 3x are the sides of the rectangular base, okay, and h be the height of the box, then what will be the volume? Volume V is equal to x into 3x into h. So 3x square h. Differentiate with respect to x, what you get? dv by dx is 3x square dh by dx plus 3h into d by dx of x square. We have to use the product rule. Now the first we will find the as we want the maximum value, the first derivative must be equal to 0. Okay, so dh by dx is equal to minus 2h upon x. This is our equation number 1. Now let S be the surface area of the box. Now you must know the formula to find the surface area of the box. Now the box will have how many surfaces? The box is a three-dimensional geometry. Look, this is so suppose this is the box. So this is one surface, this is one surface, this is another surface, this is another surface, this is topmost surface. Okay, opposite 1 2 3 4 and in top and bottom, so there are 6 surfaces. So how to find the area? We have to find the area. So first 2 into 3x squared. So one of this again I will explain you. The one box, one side of the one surface is having length x centimeter and breadth 3x centimeter. So there are two surfaces like that. So the area is 2 into 3x square. Now there is another one, another surface, another side of that particular box is having x centimeter length and h centimeter height. So its area is x into h. Now they are 2. So 2 times xh. Again, there is one surface whose length is 3x and height is h. Length is h. So its area is 3x into h. So they are also 2. So 2 into 3xh. So take the sum of all those, you get the surface area. Now differentiate with respect to x, we get ds by dx is equal to this equation. Now we will put dh by dx is minus 2h upon x in this equation, and then simplify. You will minus 12x minus 16h minus plus 8h. This is the ds by dx. Now what they asked, the total surface area of the box is minimum. So for this surface area is to be minimum, the ds by dx must be equal to 0, and ds by dx is equal to 0 implies we get a height of the box is 3x upon 2. Now again differentiate this surface area with respect to x. What you get? We obtain 12 plus 16h upon x. So for both x and h are positive, so this second derivative is also positive. So the surface area of the box is minimum when the height of the box is equal to 3 by 2 times shorter side of the base. If this is the condition, then there will be a surface area of the box is minimum. So these are the solved examples from the textbook. In next lecture, we will solve the examples from our exercise.